All right, let's dive into a really fascinating question today. With all the amazing technology we have, what would it actually take to build a simple artificial brain completely from scratch? You'd be surprised how tricky the answer is.
I mean, it seems like a question we should have an answer to by now, right? We've got insane computing power, we know a ton about neuroscience, so you'd think making a basic digital creature that can just survive in a simple world would be, well, simple. But here's the thing, we can't, and that is the central mystery we're going to unpack today.
So, the heart of the problem is something you could call a grand scientific gap. For years and years, scientists have been building amazing models of parts of the brain, like the hippocampus for memory or the basal ganglia for making decisions. It's like we have a complete parts list for a car, but we've totally lost the assembly manual. We just don't know how to put it all together to make it run.
And this slide really nails the difference. On the left, that's where we are now. Our models are super abstract, they focus on one tiny little task, and they often use these kind of over-engineered neurons. But the goal, over on the right, is something way bigger. It's a brain that is embodied, it has a body, and can actually function in an environment. A whole integrated system. This brings us to a really important idea, embodied cognition. The theory here is that true intelligence isn't just about pure math happening inside a computer chip. Nope, it grows out of that constant conversation between a body, what it senses, what it does, and the world all around it. You just can't separate the brain from the body it's trying to control.
So, to try and close that huge scientific gap and really put this whole embodied cognition idea to the test, a brand new competition was born, the BrainCraft Challenge. It's this awesome hands-on attempt to push things forward where just thinking about it has kind of stalled out.
The mission sounds pretty straightforward, doesn't it? The contestants have to design a neural network, basically a mini brain, to pilot a little bot. And what's the bot's one and only goal in life? Just survive. And the only way to do that is to find and eat energy before its own battery runs out.
Okay, but this is where it gets really hard. See, the challenge isn't just to build a working brain. It's to build one that works under some very tough rules. These constraints are what make this a true test of cleverness.
First off, the size. The entire artificial brain can have at most 1,000 neurons. That's it. For a little perspective, a common garden slug has 10 times that many. So whatever design you come up with has to be unbelievably efficient.
Next up, time. The contestants only get 100 seconds of computer time to train their model. Not days on a supercomputer, not even a few hours, 100 seconds. The learning has to happen at lightning speed.
And finally, the test itself. The bot's final score isn't just from one good run, it's the average performance across 10 separate tries. This makes sure the solution is solid and not just a lucky break. So let's just recap. 1,000 neurons, 100 seconds to learn, and 10 trials to prove it works. The pressure is on.
So how does all this play out in the actual challenge? Well, let's look at the very first hurdle everyone has to clear. Task 1. It's designed to look super simple, but with those rules in place, it is anything but.
Okay, so here's the world. The bot starts right in the middle of this maze, and there are two places where an energy source might be. At the beginning of each run, only one of those spots becomes active, and the bot has absolutely no idea which one it is. It has to figure it out, choose the right path, and get to the energy before it dies.
And this setup is just brilliant because it shows you how complex this simple task really is. The best strategy isn't random. It requires memory, it requires decision-making. The bot has to go check one path, and if there's nothing there, it has to remember that it already checked, and then try the other path, and once it finds the energy, it needs to lock onto that loop to keep refueling. This is so much more than a simple reflex.
So, with these brutal rules and this deceptively simple task, how did the first submissions actually do? Let's take a look at the results. First, we need to know what failure looks like. That's the stupid random bot on the left. It just wanders around hoping for the best. Its survival chance is practically zero. On the right, that's the goal, an engineered bot that actually follows a strategy. The distance between these two is really the measure of success.
And here are the scores. The score is basically how far the bot traveled before it ran out of energy. Look at the very bottom, the random bot gets a truly terrible score of 1.46. But now, look at the top. The engineered solutions, the ones using handcrafted designs or genetic algorithms, scored 12, 13, even 14.71. That is almost as good as the human player's score of 15. The takeaway here is huge. It's possible. It's really hard, but with a clever design, you can do it.
You know, this whole thing is about so much more than just getting a high score in a simulation. The philosophy behind this challenge is pointing toward a whole different way of thinking about what intelligence even is. One of the most mind-bending parts of the design is this. Contestants are forbidden, like it's against the rules, to give their bot an external reward signal during training. Just think about that for a second. How is the bot supposed to learn what's good if you can't tell it?
And this is the awesome, provocative answer from the person who created the challenge. The idea is that a truly intelligent creature shouldn't need a scientist to give it a gold star. It should be able to figure out its own motivation. It should feel its energy going up and learn, all by itself, that that's a good thing for survival. But that little question at the end, is it? That's the whole point. It's a hint that this is much harder than it sounds. And that really brings us right back to the ultimate goal. The BrainCraft Challenge isn't trying to build the most powerful AI in the world. It's trying to force us to create a complete, self-contained system, a tiny, synthetic organism that perfectly connects what it senses to what it does, all for one single purpose: survival. So let's end with this thought. By focusing on embodiment, on these tight constraints, and on this idea of internal motivation instead of just massive brute force computing, is it possible that solutions to this simple little game could actually show us some fundamental principles for building a smarter, more efficient kind of artificial intelligence in the future? It's a question we're thinking about. Thanks for tuning in.